Hello everyone, it's March 27th. It's a bit late today. It's actually very, very late today. So we have actually a hard deadline for 12 a.m. right? So it's 10:18 p.m. right now. So we have to do it well, otherwise we're gonna miss today's goal. All right, let's do it. Before we start, take a look here. I think I commented here. Is that? No, I don't think that's something from yesterday. Anyway, let's go for it. Palindrome substring. Did I do this before? Huh. Maybe, maybe not. Let's take a look. Given a string, I've definitely done a lot of palindrome in the past. Your task is to count how many palindromic substrings in this string. So substring is different from a subsequence. Substring cannot be, it has to be consecutive. I think that's what substring is. Substring with different start indexes or an index that can count as different substrings, even they consist of same characters. With different start index also, even if it's the same, but if it will start differently. Yeah, I think I've definitely done this before. Because I remember this is a pain, total pain to do this. But we have 16 total. Yeah, A. Yep. Alright, input string won't exceed 1000 in length. Ooh. Okay. So, a substring. No clue, honestly, right now. I mean, we can do like length 1, length 2, length 3. Yeah, we can do that, right? So, given a string, length 1, all of them are palindromes, so no need to worry about that. Length 2, we could just do, because it's substring, it's not subsequence, so we can do slide window, just like 2, 2, 2, 2, 2, and then 3 will be 3, 3, 3, 3, 3. So it's going to be length from 1, and then we're gonna do 1000 times. Length 2, 1000 times. So it's gonna be O(n) squared. Yeah, I think that's it. All right, let's give it a. I don't even have a test case. Let's give a test case. So let's say this. All right, this shall be 3, 4. This is 4. So return whatever. This is 4. I'm just confirming that it is substring. 5. Oh yeah, it's 5. It's actually 5. All right, I think we can do it this way. Just count from 1, 2, 3 all the way to the end. We're gonna do copy from yesterday, and from yesterday. This is gonna be from today. Alrighty, let's try it. See if this scheme works. I mean, given it's only 1000 length, I think it's working. So O(n) squared is within reach. O(n) squared definitely within reach. Oh, I can't delete it too much. Yeah, probably don't need deck. All right. So what we're gonna do is we're gonna start from 2 all the way to the end, and we're gonna use. Hold on. And waste a lot of space, but doesn't matter. All right, I'm gonna go say res equals len s, and then for L in range 2 to len s plus 1. Right, we're gonna say for I in range len s minus L. Right, so if it's len s minus L minus 2, S1 minus 1, 2. So plus, we're gonna do I and I plus L, right? So it's 0, 0 plus 2 will be 2, so it's 0, 1. Okay, so if we have the length is 3 and I wanted 2, I want to do so with 0 and 1, so that's 3 minus 2 is 1. Shouldn't we plus 1? No, we shouldn't. If we do 2, 3 minus 2 is 1, so we can do 0. No, I think it should be minus. It should be plus 1, right? Which means if length is 1, yeah, it should be plus 1. So we're gonna say if S, gonna be a lot of splicing. Si to I plus L equals S. Let's splice it once. Sub str equals S. Yeah, so kind of, I think we'll save some time. And then we say if sub this equals sub this, then we say res plus equals 1. Then we return res. Okay, the test case is ABC, give us 3. ABAC, give us 5. And then 1, 2, 3, 4, 5. Then we have 5, no, 4. 3. Okay, give us 6. And we're going to say S count. Alright, check it. We're good. Ambiguous, that's fine. We're doing LeetCode. Don't worry too much about this. Submit. I hope it doesn't time out. Yep, I got this. Yeah, because there's only 1,000, so I think it's doable. We simply check length of 1 all the way to length of len s. For each length, we traverse the entirety of S, taking substring of size of the corresponding size. Let's use a new one. Corresponding size. Since the size of S is only 1,000, this method works. So it's O(n) squared, right? Because we do, this is O(n) and this is O(n) as well. So we have O(n) squared, which runs at how much? Oh, ha! So there are much better solutions. All right, that's interesting. 672 milliseconds. I run at 8% ranking. Hey, if it's a contest, we at least pass. Based on the ranking, it seems that there exists a better solution. Okay, let's give it a little bit of thought before we jump into the provided solution. I mean, because it's fine, we already solved it, so we don't have to worry. Yeah, they have a solution here. Okay, let's think about it. It could be this is slow, so we're basically creating another string every single time. So if we don't do this, maybe it'll be faster. Let's try it. What if we don't? So we have I, right? And then we're gonna say left, right equals I, That should be a new solution. Let's do this as a new solution. Oh, excuse me. Let's try this as a new solution. See if it's any faster. So basically, you want to say left, right equals I and I plus L minus 1. All right? Yeah, and then we say while left is smaller than right, if S left is not equal to S right, then we're going to break. And else res. Yep. Solution 2. Oh, shoot. I forgot to increment. Left plus equals 1. Right minus equals 1. Okay, then we try it. There we go. Alright, let's see if this one's faster. As we avoided, there's no string copying, so I hope this one will do better. Okay, we just say without splicing string, the original string. All right, let's try it. See if it's faster. Pending, judging. I don't think so. Oh wow, this one actually. Ha. This is faster. The substring is faster. Well, of course, you thought that you do the substring, at least it has some internal speed up. This ain't gonna work, man. Ain't gonna work. Not going to work. Okay, so this is not going to be working. So this is actually TLE. Apparently, splicing has some internal optimization. Of course it has optimization. You think you can be faster doing this way? No way. No way. All right, so that's not the solution, right? That's not the solution. There gotta be a. Look at the spread. This one is at what? At 8%. So there gotta be a better one. I mean, if you think about it, if we find a palindrome, say we go from big to small. If we find out that the big one, yeah, I definitely done this before. I kind of remember this analysis. If the big one is a palindrome, then we can be sure that, so when we find a big palindrome, then we have a lot of multiple smaller palindromes, right? Yeah, think about it. If we have A, B, B, C, right, and then B, B, A. So this whole thing is a palindrome. What, is it too small? Yeah, I feel like it's too small. Anyway, if this is a palindrome, then we can be sure this is a palindrome. And this is a palindrome. This is a palindrome. This is a palindrome. Alright? I can be sure. So if we find one, we can find a bunch of other palindromes. So that means if we find the biggest, then we know the remaining within this range. But it is also possible that, and based on the center, right? So if we have the big one centered at the center, and then we do this trick, and then if we shift to the left and shift to the right, and this will be a different center. Huh. So we do have to check different lengths. No, we don't have to check different lengths. We check at each position, right? We're given the string, we check at each position, and then we get all the palindrome using this position as its center. Hold on. What if it's this? There's no center. Well, in that case, if we add something in between, say we add, I didn't say like the letters are. Yeah, I think we can just we add this to each one of them, right? That we can be sure the center is either the letter itself or this, right? So we're going to start from here. We're actually going to add it to the front and back. So we know this, we're going to start from here. And then we look to the side, and that is 1, right? And then this one cannot go anymore, so that's it. We'll move on to this one. This one, we look to the side, that's 1, that's 1. I look to the side, and if it's this, we are going to skip, because that's basically the same. So we're going to skip when we find our separator. And next is this, and this. So do I even have to? So I don't think I need to add another one. So we know that when we start, it's always by itself, and then we look to the left, there's nothing left, so we say no. So here, we get there, that's good. Keep going, no. So we'll go here. We know by itself is good. And then we always skip this, so we find A and B, that's no good. Keep going, here, A and B, that's no good. B, A and B, that's no good. Here, B and B, oh, that's good. We have BB, keep going, that's no good. So basically, we use every single one as the center, and we just try to expand on both sides and see how far we can go. So isn't this the same? I feel like this is the same as this one, because you have to go every single letter, because every single letter can be used as the center. And then at every single letter, you're gonna expand. How far you're gonna expand? Well, that depends. So if it's like a relatively random string, it's not gonna expand as much. So it might be. I mean, the worst case scenario is just everybody's the same. So you have to expand all the way, right? That's the worst case scenario. Let's try it, because this one times out. Because this times out because we're trying to use length, so we have all the length. So each length we have to go through the entire thing. For each length we have to go through the entire thing. I feel that's the same. Well, let's give it a shot. If it times out still, then we're gonna try to check, see if there's any smarter solution. Yeah, this seems very familiar. It's very, very familiar. So we're gonna say s underscore equals s dot split, right? And then we're gonna say this dot join s dot split, right? And then we're gonna say for I. Not for I, for I. Yeah, for I in range len s, right? Res equals 0. Each I res plus equals 1 by itself. If si is not equal to this, then we do this, right? Plus equal 1. And then when it's C, left right equals I minus 1 and I plus 1, right? While left is larger equal to 0 and right is smaller than len. For len we use it multiple times, so we're going to say n will be len s. Okay, so we all switch this to n. I like to do larger n. And then it's going to be n. While this and s left equals s right. Right? If it is, then we can rest plus equal 1. Actually also have to and can I say, that's a good question. I have a question. A is, let's say, S, oh what the heck. B is S, C is D. A equals B equals C. This is false. A equals B not equals C. Oh, we can do this. Or A not equals C, but equals B. That's false. I don't know. What's the, when we chain it together, I think it's doing just this, and this, and this, and this. I think that's how it's been done. If that's the case, then I think we can do it. We can just say not equal to this. Oh, that's gonna, no. Then we say if s left is not equal to this, and we do this, otherwise left minus equals 1, right plus equal 1. I think we can start from I, and we can avoid doing this. Right? Just start from this position, and we say, yeah, of course, it's the beginning. And then we say if it's not, if it is, we just left go left, right go right. And then when we're done, we keep moving. So we're banging on average, this will not extend all the way to the end. Alright? Then that's it. We're going to return res. Let's try solution 3. I forgot to put the colon. Oh my god. Okay. This was not correct. How? We got 4, answer is 6. So start from here, we get a 1, and that's it. Going here, got 1. Hold on. It's actually a little bit more complicated. Let's print out the S. What is this? Why is not how I imagine it to be? That's strange. Oh, shoot. Oh, it's not split. It's list. Aye. Okay, how do all these all pass? Okay. Let's see if this one or timeout. Hope this one does not. Let's just take a look. See how long it takes. I mean, this one won't take too long because it's 280 milliseconds. Let's try it. This one accepted. Do we have a better runtime on this one? Oh, much better. Much better. Yeah, because this is like this one, the full ON squared, right? And this one does not have the optimization of the string operation, so it just times out. And this one is ON, and each one of these is not like a full. It depends. Sometimes I only do expand once. So this one, the worst case is all A's. That's the worst case. So this one has much better performance. Much better performance. Although, although the worst case is still ON squared when S consists of the same letter. On average, it has close to ON performance because the expansion will not cover the entire string. The ideal is to treat each letter in S or each position between two letters as the center of a potential palindrome. Then we expand left and right word, right? And count how many palindromes can we form. Palindromes can we form based on for each center. To facilitate this operation, we artificially insert a dummy letter to unify both odd number and even number palindromes. Right? I think this is good enough. So we still call it ON squared, worst case, and ON best case. Like this one is ON, 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 and O. I'm saying this is best case and worst case is always ON squared. Best case. How would you calculate average? Average case is also ON, right? And then we hit a 248 milliseconds or 49% ranking. Let's put this on a new line. 248 milliseconds and 49% ranking. All right, now I'm comfortable going to the official solution. All right, let's take a look. We've done this before. I am positive that we've done this before. Where does your positivity come from, man? You've not done this before. It's a medium question. Okay. What is palindrome? Check all substrings. It's gonna time out. Oof. Dynamic programming. Nice. ON squared. Expand around possible centers. Yes. This is what we... Further thoughts. Oh my god. Oh wow. People have really good... Alright, we're gonna read this. Okay. Yes. Look at all substrings. No, we're not going to do that. So they will escape. Okay. Particular substring is palindrome. Okay. We're using previously calculated results. Checking whether a string is a palindrome or not is a good candidate for dynamic. Oh, really? Two necessary characteristics. Optimal substructure. Ah, yes. The string is made up of a palindrome. Helps determine if the string itself is a palindrome. The first and last character match, so it's a potential palindrome. If we knew already that its substring is a palindrome, then this one is a palindrome as well. Yes. Results of string relies only on the optimal result for just one subproblem. Yes. That's a dynamic programming. Also, strings of a large string need to check some smaller substrings for the same repeatedly. If we store the results, yeah. For the string, the substring Bob needs to check for the substring. Yes. Single character string O needs to be checked. Yes. So this is basically the same. The same as this one, right? We go from the center. Yeah, that's like the substring comes up. If it's a palindrome or not. So as we go through it, so it's two levels, right? We have two levels, and then these are all true, right? And then double, that's also we handle these first, and then because we're gonna just iterate through all the diagonals, right? All the diagonals we handle it, and then I and I plus 1, we handle some of them, and then at the end we're gonna just go row by row, right? Row by row, and then we just like I and I plus m will depend on let me think. I and I plus m will depend on ij will depend on I plus 1 and j minus 1. Right? Ij will depend on I plus 1. I plus 1 will be a lower I minus j minus 1. So it's going to be the lower left corner. So for every cell, it depends on the lower left corner cell. If we do the diagonal first, because it's I, we all know that, and then the next one we do, let's say 0, so we do 0, 0, 1, 1, 2, 2, blah, blah, blah. And then we do 0, 1. Right? 0, 1 will be determined. No, 0, 1 is a special case. So we're going to do all the special case as well. So special case 0, 1, 1, 2, 2, 3, right? These are special case. So that's also a diagonal. And that diagonal is like up, right? And also the DP table is going to be upper right triangle. We don't have to worry about the lower left. So our actual DP solution is going to start from 0, 2, right? This is our first one. So from 0, 2. So 0, 2, we want to know is 1, 1. 1, 1, we already done it from the previous one. So we check, and then we cannot do 0, 3 because 0, 3 requires a 1, 2, and we haven't done 1, 2 yet. So we're going to just go diagonal. So it's going to be 0, 2, 1, 3, 2, 4. That's all going to all go diagonally. Yeah, it's good. And of course this, yes. Okay, so these are all true. Single letter, double letter. Yeah. Well, your answer starts. Answer starts at 0. And answer a plus, okay. So, and then len equals 3. So length, okay, so for 3, I equals 0. J is, yeah. Oh, yeah, we can do that. Yep. Oh, so it's the same structure as this one. Ah, same structure as this one, right? But we use dynamic programming. Very good. Very good. Yeah, only depends on just like one layer, so we can just use one of them. You remove the boundary characters and you're left with another smaller palindrome. Yeah, this is basically also dynamic, but it's like just slightly different. Different way of thinking it. To choose a character at the center, one can see that the palindrome V are possible. However, the final is not because the first is so. Every single character is the center if possible. Every pair of consecutive is the center. Yeah, it's the same. Oh, around center. Oh, subquadratic time. Let's use binary search with a fast rolling hash algorithm. What the heck is this? Largest parameter for each of the centers. Oh man, palindrome tree. What the? Within a string. Tree construction takes linear time to be counted while constructing the tree in O(n) time. How many distinct palindromic substrings? How frequently each? Oh my god. Suffix arrays. What the? I just read through this. I don't even want to know what these actually mean. Oh my god. This is diving deeper into this problem. Miniatures. Oh, I remember this one. I remember this name. Oh. Yeah. I remember this. I remember this. Ha. This name is familiar. Wow. Somebody must have implemented extend palindrome. Yeah, I think extend. Oh my god, he wrote a one-liner again. Ah. That's not the point. That's another point. Anyway, I'll try to read this again, but I probably won't. I remember implementing this once for one of the problems, and it's very, very complicated. But it's good. It is O(n). It is O(n). 6 lines. How many lines do you have? Not too bad. I mean, they just put this in one line. I could have put them in one line as well. It's the same idea. Anyway, that'll be it. That'll be it for today. The miniatures, I might read it, I might not. Depends on how I feel. But for now, I'll just say that's it for today. We did a good one. I mean, yeah, we solved it using the actually not supposed to pass. I don't think this one is supposed to pass. Maybe it is. Maybe it is, but it's pretty bad. We start with, but we figure it out. We figure it out. Palindrome is onion. We look for the center. All right, that'll be it for today. I will see you guys tomorrow. Adios.